Hello class 10 students. Today I will teach you few numerical problems from chapter 12 electricity. Page number 225, example 12.8. Look at the question. In the circuit diagram given below, where the resistors R1, R2, R3 having values 5 ohm, 10 ohm, 30 ohm, which have been connected to a battery of 12 volt, calculate the current through each resistor and total circuit resistance. This diagram is already given to you, that is battery, closed switch, ammeter to measure the amount of current. Current is flowing from positive direction to negative direction. Here one voltmeter is fitted. Same voltage will pass from X to Y. But for parallel connection, you know that current will be splitted. One part will go to R1, one part for R2, one part for R3. In this question, we are going to calculate current through each resistor, total current and total circuit resistance. To start this answer, first you can write the given materials. Here R1 is 5 ohm, R2 10 ohm, R3 30 ohm. Total voltage is given 12 volt in the question. So V is equal to 12 volt. This V is the symbol for potential difference, voltage, and 12 volt, this V for volt as a unit. Now current through R1, as per Ohm's law, I is equal to V by R. So current through R1 you can mark as a I1, which is equal to V by R1. V is 12 volt, R1 is 5 ohm for the first resistor. Divide this, get it 2.4 ampere. Same way you can calculate current through R2 and current through R3. So current through R2 you can mark by I2. I2 is equal to V by R2. Formula according to Ohm's law, I is equal to V by R. So V is 12 volt, R2 is 10 ohm. Instead of cancellation, make it decimal directly, 1.2 ampere. And current through R3 you can mark by I3, which is equal to V by R3. Third resistance is 30 ohm and voltage same, 12 volt. By 3 you can cancel it, so it will be 4 by 10. Then make it decimal, 0.4 ampere. So current through each resistor we got it. One is 2.4 ampere, second one 1.2 ampere, third one 0.4 ampere. Now question number B. Total current in the circuit I is equal to I1 plus I2 plus I3. Let us add all these values, 2.4, 1.2 and 0.4. After adding you will be getting 4 ampere. Now finally they are asking total circuit resistance. As all the resistances R1, R2, R3 are connected in parallel, then total circuit resistance Rp, because of parallel connection, is given by formula 1 by Rp equals to 1 by R1 plus 1 by R2 plus 1 by R3. So 1 by Rp equals to 1 by 5 plus 1 by 10 plus 1 by 30. LCM for all these, 30 only. Left side keep it 1 by Rp. 5 6 are 30, 6 1s are 6. 10 3s are 30, 3 1s are 3. 30 1s are 30, 1 1s are 1. After addition you will be getting 10 by 30. After cancellation it will be 1 by 3. Let us do the cross multiplication. Rp is coming out 3 ohm. So total circuit resistance 3 ohm. Since all are connected in parallel, that's why I have taken this formula. 1 by Rp is equal to 1 by R1 plus 1 by R2 plus 1 by R3. Now let me teach you another question. Example 12.9, page number 226. Here also one figure is available. Total 5 resistances where R1 and R2, R1 and R2 are connected in parallel. R3, R4, R5 also connected in parallel. They have different values according to the question. R1 10 ohm, R2 40 ohm, R3 30 ohm, R4 20 ohm, R5 60 ohm. Total voltage is also given 12 volt. Asking question, calculate total resistance in the circuit and total current flowing in the circuit. Diagram should be drawn perfectly. Then you can write all these resistances: R1 10 ohm, R2 40 ohm, R3 30 ohm, R4 20 ohm, R5 60 ohm. Voltage V is equal to 12 volt. As for the figure, R1 and R2 both are connected in parallel, so we need to combine their resistances. R3, R4, R5 also connected in parallel, so here also we need to combine their resistances. After this combination and after that combination, both the combined resistances will be connected in one line, that is series connection. By this way you can get it total circuit resistance. After that, total current. So number A, to get total resistance in the circuit, first what I have done, now as the resistances R1 and R2 are connected in parallel, then total resistance RP1, I have taken RP1, that is for first parallel connection, which is equal to formula 1 by RP1 equals to 1 by R1 plus 1 by R2. RP1 I have taken for first parallel connection. Then R1 and R2 you can put it 1 by 10 plus 1 by 40, LCM 40, upside 4 plus 1, which is 5 by 40. After cancellation it is 1 by 8. So do the cross multiplication. RP1 is coming out 8 ohm. So first combination, combined resistance, equivalent resistance. For the first parallel connection RP1 we found 8 ohm. Again as per the sketch, R3, R4, R5 also connected in parallel. So as the resistances R3, R4, R5 are connected in parallel, then total resistance RP2 is given by 1 by RP2 equals to 1 by R3 plus 1 by R4 plus 1 by R5. Put all the values, 1 by 30 plus 1 by 20 plus 1 by 60. LCM is coming out 60. 30 to the 60, 2 1 the 2, plus 23 the 60, 3 1 the 3, plus 61 the 60, 1 1 the 1. So 1 by RP2 equals to, addition is coming 6 by 60, that is 1 by 10. Do the cross multiplication. RP2 is equal to 10 ohm. So first parallel connection, combined resistance we got 8 ohm. For the second parallel connection, combined resistance, equivalent resistance we got it 10 ohm. Now RP1 and RP2 both will be connected in one line, that is series connection. Because both the parallel groups I have combined, after combination RP1 and RP2 will be connected in series. Then total resistance in the circuit RS is given by RS is equal to RP1 plus RP2, that is 8 ohm plus 10 ohm. It becomes 18 ohm. This 18 ohm is the total circuit resistance. Now second question, to get the total current in the circuit. Number B, as per Ohm's law, we know the formula I is equal to V by R. But here R is total resistance, that is RS. So V is 12 volt, RS, that is total resistance, is 18 ohm. By 6 you can cancel it, it will be 2 by 3. Let us divide this, you will be getting 0.67 ampere. Therefore total current flowing in the circuit is 0.67 ampere. So today only two numericals, example 12.8 and 12.9. Practice very well. Bye for today.